In this lesson, we'll start our discussion of learning target number 6, determining the empirical formula of an unknown compound from percent composition. Determining the empirical formula is the next step in identifying an unknown compound. In this method, scientists use the fact that atoms combine to form compounds in whole number ratios. This was first stated by John Dalton. This means all formulas must have whole numbers. You can never have a fraction of an atom included in a stable structure. For example, water is H2O, not H2.20. Some terminology differences. The molecular formula is defined as showing the actual number of atoms that make up each molecule or formula unit for the compound. For example, glucose, a common sugar, is C6H12O6, or magnesium fluoride is MgF2. The empirical formula shows the lowest whole number ratio, or the simplest formula for the compound. For example, the empirical formula for glucose is reduced to CH2O, and the empirical formula for magnesium fluoride is MgF2. Notice that the formula for ionic compounds are always the same. This is because they're always written in the lowest terms, so their molecular formulas and the empirical formulas are the same thing. Once you've found the empirical formula using the method in this lesson, you have identified the molecular formula of the ionic compound. For molecular compounds, there is an extra step, because it's possible for different molecular compounds to have the same empirical formulas. Have a look on page 269, table 6.1. It describes many molecular formulas and their properties, and they all have the same empirical. The extra step required to identify an unknown molecular compound is described in the molecular formulas note. Here are the steps in the method defining the empirical formula. Let's run through these with example 1. We're told that an unknown compound has an 81.89% carbon, 6.12% hydrogen, and 11.99% oxygen. Step 1 for determining the empirical formula is to find the mass of each piece in the formula. Now, if you're given percent composition, like we are in this question, an easy mathematical trick to use to achieve step 1 is to take a hypothetical 100-gram sample. If I have a 100-gram sample that is 81.89% carbon, then I'm going to have 81.89 grams of carbon. You can take any size sample that you want, but if you choose a 100-gram sample, all you have to do is flip the percent signs to grams, and you've achieved step 1. I like to make a little organization chart here. I'm going to do all my carbon calculations here, all my hydrogen ones, and all my oxygen ones. And I'll keep them separated with some dashed lines. The same trick works with the hydrogen and the oxygen. If I've got 6.12% hydrogen in a 100-gram sample, then all I have to do is change the percents into grams. Step number 2. Find the moles of each piece of the formula. Chemical formulas are written by the amount of particles, not the mass. So I need to change these grams into a unit that describes how many particles I have. So if I take my mass and divide by my molar mass, this will now give me moles of carbon. Now my calculator gives me a whole bunch of numbers. I'll just write down the first 5. I have to do this calculation for each of the elements that are in the compound. Looking at these mole numbers, I now have the ratio of each element to each other. However, I don't have whole numbers. To manipulate them, I divide each of them by the lowest number that I calculated. That's going to be my oxygen value. That gives me 1 oxygen. If I use my calculator to get the other ones, I get here 9 and I get here 8. Now, I did a little bit of rounding. There are some special rounding rules when you're determining an empirical formula. If they're not listed on your note, add them up here. If the decimal place that you get after dividing by the lowest number is greater than or equal to 0.90, then you are allowed to round up to the nearest whole number. If the decimal place you get is less than or equal to 0.10, then you are allowed to round down. The reason why we have these special rounding rules is because if it's 0.5 or above, you're rounding up by a whole atom, and that creates a lot of error in your experiment. If you can't round, so if you're between 0.10 and 0.90, follow with step 4. Multiply all of your numbers by a factor somewhere between 2 to 6. One of these options will give you a whole number. Take the one that is the closest. Finally, now that I have my whole number ratio, I can write my empirical formula. I have 9 carbons, so C9. I have 8 hydrogens, so H8, and 1 oxygen. I usually include placing a 1 beside any single element. This is just an empirical formula, which means that the unknown compound could be C9H8O, or it could be any multiple. It could be C18H16O2 or C90H80O10. I often include the 1 because it reminds me not to lose it when I determine the molecular formula of this compound. Example 2 requires us to implement step number 4. It's the same type of question. We're given percent compositions and we're asked to determine the empirical formula. To achieve step 1 easily, I'm going to take a 100-gram sample. This compound just contains carbon and hydrogen. In a 100-gram sample that's 81.7% carbon, I'm going to have 81.7 grams of carbon and 18.3 grams of hydrogen. Step number 2, I'm going to change these grams into moles by dividing by the molar mass. My calculator gives me lots of digits. I'm just going to record the first 5. Step number 3, divide each by the lowest number. That's going to be carbon. This gives me 1 carbon, and my calculator is telling me I've got 2.66 hydrogens. Now I can't round this. I have to employ step number 4. Now, if you recognize that 0.66 as a fraction is 2/3, then that's one way to identify you need to multiply by 3. If you don't recognize that fraction, then multiply 2.66 times 2 and see what you get. If it's not a whole number, try 3. If it's not a whole number again, try 4. Guaranteed you will get something that is between 2 and 6. Now I can write my empirical formula. C3H8. Try out the empirical formula questions on your assignment checklist.